4.9 on page 40 as well, and this is the multiple choice. These are the kind of problems that you would expect as multiple choice. So let's take the go into the problem immediately, and we know this is 4.9, and we will say root 3. Now do the expansion. Sine x cos 30 plus cos x sine 30 plus sine x cos 60 minus cos x sine 60 degrees. Simplification of each one, we'll just keep the root 3 outside, and that is root 3 over 2 sine x, and that is a half cos x. And for your denominator, the other part, sorry, not denominator, plus that will be half sine x minus root 3 over 2 cos x. Now here you'll notice root 3 times root 3 is 3 over 2 sine x. 3 over 2 sine x plus half sine x is 4 over 2 sine x, which is 2 sine x. And then here you've got root 3 over 2 cos x minus the root 3 over 2 cos x is 0. So you got 2 sine x, and it's your option D. This is a section on double angles. Now before you can go on to double angles, you need to complete all the remaining problems on the previous page. Now your double angles, essentially, we are saying you got cos A plus sine A is equal to x, cos A minus sine A is equal to y. Then write cos of 2A in terms of x and y. Now suppose cos of 2a is cos of a plus a, then we can use this as a double angle, but wherever we have the b, we replace it by a. So this is cos a cos b, which is now becoming cos a minus sine a, which is cos squared a minus sine squared a. Now cos squared a minus sine squared a is cos of a plus sine of a into cos of a minus sine of a, which is obviously the difference of two squares, and you are given them as x and y, so cos 2a is xy. So that's your first derivation. Cos of 2a is cos squared a minus sine squared a. Now if you replace cos squared a by 1 minus sine squared a, you will get the second expansion for cos 2a. And if you replace sine squared a minus sine squared a, if you replace the sine squared a by 1 minus cos squared a, you will end up with 2 cos squared a minus 1. Now if we take sine 2a, sine 2a is sine of a plus a, which is sine a cos a plus cos a sine a, which becomes 2 sine a cos a. Then if you do the same for tan of 2a, tan of a plus a, which is tan a plus tan b, that becomes tan a plus tan a all over 1 minus tan a times tan a, and you will get 2 tan a over 1 minus tan squared a. So now we will do applications on double angles specifically. The application on double angles, you got cos a plus sine a is equal to 1, 4, cos a minus sine a is equal to 0, 2. Find cos 2a. Now cos 2a, you will notice now we've got difference of two squares. So if I multiply both of them out, cos a plus that times that, I will get cos squared a minus sine squared a, and all I need to do is to multiply 1, 4 by 0, 2, which is 0,28, and that's cos of 2a, which is 0,28. Then the next problem is sine 2a. Now there are two ways of doing it. You can add them, and you will get, if you add the two, you will get 2 cos a is equal to 1.1,6, and if you subtract the two, then what would happen is you will get 2 sine a is equal to 1.2. And then what happens now, if we, let's say, divide, just let's say for argument's sake, we divide that 2 cos a, we can get 0,8. Now if I multiply both these, 2 sine a cos a, I will get 1,2 times that, which is 0,96. And then 2 sine a cos a is sine 2a. That's a lovely problem. Now this is in 4.1, which is on page 41. You are actually given that cos of theta is equal to minus 4 over 5, and theta is an element of the first two quadrants. It can't be in the first, it has to be in the second quadrant. And then we know that this is x over r, and y in the second quadrant is positive 3. So 4.1.1, tan of theta is y over x, and keep in mind the x value is minus 3, so it's minus 3 over 4. And then we got 4.1.2, which says cos of 2 theta, and that can be written as 2 cos squared theta minus 1, and that's 2 times, square that, which is 16 over 25 minus 1, and that gives you the answer 7 over 25. The answer is 7 over 25. And then 4.1.3 is sine 2 theta, which is 2 sine theta cos theta, and that gives you 2 times 3 over 5 times minus 4 over 5, and our answer is minus 24 over 25. Then if you look at 4.1.4, we have the problem on sine of theta minus 180, theta minus 180, and then you change that sine of a negative angle is negative sine of the positive angle, and the positive angle, this is second quadrant and sine is positive there, so we're looking at negative sine theta. And then negative sine theta, we've got sine of theta is 3 over 5, so this is minus 3 over 5. Then we're looking at 4.1.5, which is 1 over cos of theta minus 90 degrees. Now this is a negative angle as well, which is 1 over cos of a negative angle is same as cos of the positive angle, and that is 1 over sine of theta. and 1 over sine of theta is 3 over 5. 1 over sine of theta is 5 over 3. 4.1.6 says sine of theta plus 30 degrees, and that is sine theta cos 30 plus cos theta sine 30. Now what we have here is sine theta, which we know is 3 over 5, times cos 30 is root 3 over 2, and then we have cos theta is minus 4 over 5 times a half. And when you simplify that, you will get 3 root 3 minus 4 all over 10. And then we got 4.1.7, which says tan of theta plus 45 degrees. And we know that is tan of theta plus tan of 45 all over 1 minus tan theta tan 45. And we know that is minus 3 over 4 for tan plus 1 all over 1 minus 3 over 4 times 1 will become plus 3 over 4, and when you simplify that you will get 1 over 7. (4.5) on page 42. 4.5. Now here we've got the problem on 3 sine x. So what I want to do, I'm going to divide the 3 over 2 sine x, and that leaves us with sine of x minus 60, which is sine x cos 60 minus cos x sine 60. And this will now give you a half sine x minus root 3 over 2 cos x. Now if I multiply throughout by 2, I will get 3 sine x is equal to sine x minus root 3 cos x. Now here if I, on the left hand side, 3 sine x minus sine x is 2 sine x, and on the right hand side I have minus root 3 cos x. Now if I divide, take the or transpose the factors, which is also fine, sine of x over cos of x is equal to minus root 3 over 2. Sine of x over cos of x is tan of x, which is minus root 3 over 2. This is 4.7 on page 42. Now if you look at 37,5 degrees, the only way we can get an angle, a special angle out of it, is to treat this as A, then 2A will be 75 degrees. So what I can do is to reconstruct this problem and say 2 cos squared 37,5 degrees minus 1, and that's 2 cos squared A minus 1 is cos 2A, which is cos 75 degrees. And we will just focus on the 75 degrees for the moment, which is cos of 45 plus 30, and that is the same as cos 45 cos 30 minus sine 45 sine 30, and then that is root 2 over 2 times root 3 over 2 minus root 2 over 2 times half. Now what we basically have is this problem, and we can now try to simplify as far as we can, which means that that would be root of 6 over 4 minus root of 2 over 4, and that would give us, actually, if I take the plus 1 on the right hand side firstly, so I will have 2 cos squared 37,5 degrees is equal to root of 6 over 4 minus root of 2 over 4, and I make it plus 1, so it's plus 4 over 4. And then what we have is, and if I divide by 2, so I will have the situation here, root of 6, so I've got cos squared 37,5 degrees, root of 6 minus root of 2 plus 4 all over 8. And then I need to find the square root of all that, so I'll get cos of 37,5 degrees. You won't get plus or minus because that's an acute angle, so you'll get the square root of root of 6 minus root of 2 plus 4 all over 8. Now you would notice that your multiple choice gives you an answer which doesn't appear like yours, but very strategically, if you actually work through this, simplifying, you will see it's actually equal to root of 3 plus 2 root 2 coming from the 4 minus 1 all over 4 root 2. Now what I've seen is actually could possibly be the case is where you're dividing each one by root 2. So if I divide that by root 2, I'll get that. If I divide this by root 2, I'll get the minus 1. If I divide the 4 by root 2, I'll get 2 root 2. If I divide 8 by that, I will get the answer. Now that takes care of double angles.